So what we want to do in this problem is we want to check if the city affects the price of coffee. So does it matter where do we order this coffee, on how much will we pay for it? So we collected this data, so there's 12 observation points, so 12 coffees, collected over 4 groups, so 4 cities. So it's a little bit of a technical hypothesis. The null hypothesis would be that all means are equal, and then we want to prove that at least one of them is different. The content of this is actually that the city does affect the price of coffee. So what we have here is 4 independent groups. So this is an extension of the independent samples t-test. So it cannot be done with a t-test, so rather it's done with an f-test where we compare the between and within group variance. So how much do city means differ and how much do the individual coffees within each of the cities differ between themselves. So in order to get to the f, so you can see here the whole calculation already, but what we do need first is we need first means for each of the group, and then we need the global mean. So what we do is by group, so in our case by city, we sum up the values and divide by the number of observations. In our case, we have 3 observations in each of the cities, but it's not necessary that we would have the same number of observations in each of the samples. So after we do this, we also compute the global mean. So essentially for the global mean, we sum up all the values that we have, so in all the groups, in our case all the cities, and divide by the total number of units. So if we would sum up all the money we spend for the 12 coffees, we spent 60 euros for 12 coffees, so on average we spent 5. And then we can proceed in calculating the variance. So before calculating the variance, we first compute the sums of squares. So first the between group sum of squares, where we take group means and subtract the global mean and we square it. Now technically expect that we would do this for every group, for all members of each of the groups, so we also multiply this with the number of group members. So in our case we have 3 group members and we take the average square difference for each of them. So the total sum of squares for all of them is 42. The within groups, what we do in the within groups is we take individual observation and we subtract the group mean, and then we square this difference. And we do this across the groups. So what you see here in this calculation is we do it first for the first group. So the mean for the first group was 5 and the individual observations was 4, 6, and 5. So we take 4 minus 5 squared plus 6 minus 5 squared plus 5 minus 5 squared and so on. We are done with the first group, so then we move to the next group where the mean is 8. And we go 6 minus 8 squared and so on until we run out of all observations in all of the groups. The within group sum of squares here is 24. The total sum of squares would then be 24 plus 42, 66. If we divide the sum of squares with the appropriate degrees of freedom, so degrees of freedom are k minus 1, the number of groups minus 1 for the between group variance, and n minus k, so total number of observation in all of the groups less the number of groups. So if we do this, we get a between group variance 14 and within group variance 3. If we divide these two, 14 divided by 3, we get the F ratio, which in our case is 4.667. We compare this to a t-distribution with degrees of freedom 3, so k minus 1, and n minus k 8. So 2 sets of degrees of freedom. At 5% significance, the critical value is 4.066, which is less than our computed F 4.667. So we can conclude that this should be true for the population as well. So we can make the conclusion based on sample data, we can confirm the research hypothesis that the price of the coffee depends on the city and make the claim at 5% significance.